Page 149. The effect of solar energy on Earth's atmosphere, hydrosphere, and surface. Recap, Section A. The Earth receives radiant energy from the Sun. The Sun's radiant energy is made up of different types of electromagnetic radiation, including infrared radiation, visible light, and ultraviolet radiation. Only a small part of the Sun's solar energy reaches the Earth. The Earth's energy budget describes what happens to incoming solar energy. About 1/3 is reflected back into space. About 1/2 is absorbed by the Earth's surface when it is transformed into thermal energy. The rest of the incoming energy is absorbed by the atmosphere and clouds. There must be a delicate balance between the reflected and absorbed energy from the Sun to support life on Earth. The greenhouse effect is what makes the Earth's temperature suitable for life. Certain gases in the atmosphere, such as water vapor, carbon dioxide, methane, ozone, and nitrous oxide, trap solar energy and keep it from escaping back into space. Without this natural greenhouse effect, temperatures on Earth would be too low. If too much outgoing energy is trapped due to excess carbon dioxide and other gases in the atmosphere, this may result in a rise in atmospheric temperature. The resulting climate change may alter weather patterns around the globe. Climate refers to the long-term weather pattern, including temperature, precipitation, and wind, that normally exists in a particular region. Several factors combine to produce different climates, including distance from the equator, latitude, elevation above sea level, altitude, nearness to large bodies of water, the presence of mountain ranges which create different climatic conditions on a windward, cooler and wetter, and leanward, warmer and drier, sides of the mountain. Section B. Solar energy powers the global circulation of the atmosphere, winds, ocean currents, and many processes at Earth's surface, including photosynthesis. Different types of matter absorb solar energy at different rates, causing the Earth's surface to be heated unequally. Land surfaces absorb and release thermal energy more quickly than water. Water is able to absorb large amounts of thermal energy without producing a significant change in temperature. Large bodies of water tend to moderate the climate of surrounding land areas by absorbing a large amount of solar energy in summer and slowly releasing that energy in the winter. Thus, extremes in temperatures are minimized near large bodies of water. When a fluid is heated, its molecules move faster and further apart. The heated portion of the fluid becomes less dense, causing it to rise. Air and water are fluids that are continually heated and cooled on Earth. The rising of warm air and falling of cool air creates a pattern of motion within a fluid known as a convection current. Bodies of water, such as oceans, rivers, lakes, etc., absorb thermal energy and water evaporates from their surfaces. The air above bodies of water becomes warm and moist. Warm, moist air is less dense, so it rises over the dense, cooler, drier air. As it rises, it gives off some thermal energy and becomes cooler. Because cool air holds less water vapor than warm air, the water vapor it contains condenses and changes into tiny droplets of liquid water. These droplets collect around tiny bits of dust floating in the air, and a cloud is formed. The unequal distribution of thermal energy in the atmosphere may result in the formation of severe storms. When land is greatly heated, thunderstorms may be formed when warm, moist air rises into the cooler air above it. Water vapor condenses and clouds form. The action of warm air rising and cool air sinking, which is convection, plays a key role in the formation of severe thunderstorms. Hurricanes form over warm tropical water and are fed by the thermal energy of that water. The warm, moist air over the ocean rises upward from near the surface, forming an area of low pressure. As the air rises and forms clouds, more warm, moist air rises into the system. The result is a storm with a spiral shape and wind speeds of 199 to 289 kilometers per hour, or 74 to 200 miles per hour. These rotate upward and inward toward a nearly calm center, or eye. This concludes the effect of the solar energy on Earth's atmosphere, hydrosphere, and surface section.